So next we'll start, the last part is chromatography. What is chromatography? It's a process of separation of different dissolved components of a mixture by their absorption over an appropriate adsorbent material. What I said, it's a process of separation of different constituents of a mixture. For example, I am taking an ink. Now when I say blue ink, correct, you see a blue ink. Ink is there, blue in color. But do you think only the blue component is being present in the ink? Of course. But maximum is a blue component. Let us say 90% is a blue component. But apart from the blue component in the ink, there are also some other components are present like red, green, yellow, orange. These are also being present. But can you see with the help of naked eyes? These components are there. Thus, when you look at the ink bottle, it appears to be blue only to you. You never know that other components are also being there. Then how do you come to know? You come to know by the help of chromatography. That a blue ink or a black ink or a red ink which appears to red to you, it does not only contain a single component, it contains some other components also present in it, which is not visible to us with the help of naked eyes. Which is not visible to us. Got it? That we can know with the help of chromatography. So hence, again I repeat, it's a process of separation of different dissolved components, because these components are dissolved in that same ink only. Like when I say red, yellow, green, orange, now these components are there, of course, in minute quantities in blue ink. When I say red ink, red component is maximum and rest of the components, blue, yellow, orange, they are the minimum, but still it is being present. Got it? Yeah. Of a mixture by their adsorption over an appropriate adsorbent material. How will you separate it? We will adsorb it over a particular adsorbent material. Over a particular adsorbent material, we are going to absorb it. So basically, the common adsorbents are your filter paper. Simple filter paper, you have seen it in the lab. That is made up of cellulose, magnesium oxide, silica gel, alumina. They are considered to be as a common, what you can say, adsorbents. Common adsorbent upon which it's going to get adsorbed. What I said, filter paper which is made up of cellulose, silica gel, then alumina, then what you can say, magnesium oxide. They are considered to be as the common adsorbents. Got it? And the solvents which are using it here you will be using a particular solvent. So solvent, generally it is water, but apart from water you can also use ethyl alcohol, acetone and acetic acid. Got it? Apart from water, you can use ethyl alcohol, acetone and acetic acid. Now mind you children, organic solvents such as ethyl alcohol, acetone, acetic acid is very useful. They are very useful because they dissolve mainly those substances which are insoluble in water. Listen carefully. Organic substances, ethyl alcohol, acetic acid, acetone are very useful in case of chromatography because they dissolve mainly those substances which are insoluble in water. Which are insoluble in water. They generally dissolve those substances which are not soluble in water. Got it? For example, which are the substances which is not soluble in water? Covalent compound. They are not soluble in water. Got it? Covalent substances, they are not soluble in water. Got it? So covalent substances means, for example, let us say methane is not soluble in water. Methane gas is not soluble in water. Got it? Then all the colors which you are seeing, they are covalent substances, they are not soluble in water. Even some precipitates are also not soluble in water, like magnesium hydroxide, or oxides like what you can say, calcium oxide, then aluminium oxide, then ferric oxide or ferric hydroxide. They are not soluble in water. They are soluble in organic solvents like alcohol, ether, then what I said you, acetone, acetic acid. Acetic acid is not vinegar which you are using in your house. Got it? Acetone which you are using in the nail polish. We are using it in the nail polish and the nail polish remover, you can see that, the acetone we are using it. Got it? In this way, what you find is that alcohol, you might be doing it nowadays, we are using the sanitizer, isn't it? There it is being used, alcohol, we can say ethyl alcohol. So in this way, what you find is that these are the different solvents and the adsorbent I said you. Got it? Which is filter paper or magnesium oxide or silica gel or whatever it is, alumina, we can say that. Now what is the basic principle which lies? But before that, let me tell you from where we got the word chromatography. It has come from the Greek word chrome, means color. because we are separating the constituents of the color, we can say that. Alright, so hence from there we got the word chromatography, we can say that. Clear? So, but nowadays it's also being applied to colorless substance also. It's not necessary color. Nowadays we apply the word chromatography in colorless substance also. Now what is the principle? Just I was saying you, the technique of chromatography is based upon the fact that the different colors, they have got different rate of adsorbent. That is nothing but they are having different solubilities in a same solvent. Different color, for example, blue color, yellow color, red color, green color, are they dissolved into the same extent in water or to a particular solvent? No, they have got different solubilities. Different component has got different, what you can say, solubilities. So that particular, what you can say, this condition, I will be using it, and we will be separating the constituents of the different solvent, constituents of the different substances. Again I repeat, it's a technique. Chromatography is based upon the technique that it's based on the fact that the different, what you can say, constituents of a mixture are absorbed to different extents by adsorbent. Just now I said, absorbed by different extents of adsorbent means their solubility is different. Their solubilities is different in what you can say in the same solvent. They do not dissolve. Some substances dissolve more, some substance dissolves less, some substance dissolves faster, some substance dissolves at a slower rate. So their solubilities is different. Their adsorbent rate is different in adsorbent. Adsorbent means where it is getting adsorbed. I was saying alcohol, acetic acid, acetone, they are the adsorbent substance, and the substance upon which it is adsorbed is nothing but is your filter paper, silica gel, and all those things. We can say that. Clear? So next is, out of many chromatography, you are using the paper chromatography is very common, which you are going to study because this is there in the syllabus. The paper chromatography, out of many other chromatography, you are using it, and with the help of paper chromatography, generally what we do is that we separate the component of the ink, dyes means D-Y-E, not D-I-E, D-Y-E, color. We separate the constituents of the color, we separate the constituents of the ink. Right from the beginning I am saying you. So we will be seeing paper chromatography. Understood what is chromatography? Again I repeat, it's the process of separation of different dissolved components of a mixture by their absorption over an appropriate adsorbent material. That is called as chromatography. We can say that. And we are having different adsorbent and different adsorbent material we are having it. So let us see what is paper chromatography. For that reason, what you need to do is that you need to take a paper at least 15 centimeter long, a filter paper you need to take it. And you drop a ink somewhere at the bottom. Suppose a drop of ink I am putting it. Let us say I am blue ink. A drop of blue ink I am putting it here. Now what will I do is that I will take this filter paper strip and I will immerse it in water which is there in a beaker. This is a beaker or a flask I have taken it. Alright, I will immerse it. Let us say it will be immersed in such a manner that the filter paper, the ink is just above the surface of the water. You can see it here. The ink which is there on the filter paper, it is just above the surface of the water. This surface of the water is just above the surface. So this is your solvent. Water is a solvent there, and the filter paper is the material. Alright, the filter paper is the common adsorbent material. We can say that. And here your water is nothing but the solvent. And what you need to separate here? The ink, the dye, the color. We can say that. We are going to separate it. So you have done it in this way. Alright, you have arranged in this way. Now what you do is that you wait for some time. Let us say you can wait for 1 day also. After waiting for 1 day, what you will find? You take this filter paper, you dry it out in the sun, and you observe it under a microscope. You observe it under a microscope. What you will see when you observe under a microscope, you will find out that this color, it goes on this color. Let us say the dark blue color, if you have taken it, it goes on, the color goes on, what you can say, faded and faded and faded when it rises higher and higher and higher. Alright, that is the color that is diminishes. We can say the blue color diminishes. Like it is dark blue, it is less dark, it is less dark, it is less. The color fades away slowly and slowly. We can say that. And the spots, which is a dark spot, it becomes less dark here, the less dark here, and the less dark here. That means you will be getting different layers here. When you will observe it under a microscope, you will be getting different layers. Alright, and these layers you will find it out when you see it clearly under microscope. You will find it may be green, it may be blue, it may be yellow, it may be orange, it may be red. In this way, different layers you will be getting it. Alright, when you will observe it. So what is actually happening is that is when you put the filter paper, what you can say, strip. Of course, here a glass rod will be there. Now, the filter paper will not lie in this way, isn't it? A glass rod, you have to take it here, and you have to stick one end of the filter paper into that glass rod. You have to that is there, and the glass rod, you will fix it in a stand. You can fix it in a stand. The glass rod in an iron stand, you can take it and you can fix it. The glass rod in this particular iron stand, you can fix it. We can say that the glass rod done. In this way, we can do it something. So now what is happening? Now this filter paper has got fine pores. Alright. Through that pores, the water is being sucked in by the help of capillary action. By the help of capillary action, the water moves. Alright. The filter paper has got pores, small pores, holes are there. Through by the help of capillary action, the water is going inside. And when water is rising slowly and slowly by the help of capillary action, this ink also goes with it, and the color of the ink slowly and slowly diminishes. It slowly and slowly fades away. That means it goes on separating into its constituents. It goes on separating into its constituents. So hence, it takes some time to separate into its constituents. So when it reaches here, as I said, you take the filter paper, you dry it out in the sun, and then you observe it under microscope. You will be getting different layers. Got it? Clear? You will be getting the layers of chromatogram. We can say that the different layers you will be getting it. Alright, so the blue color ink, now it separates in different layers, we can see. And the different layers means the different components you will be observing. If you observe still under a high powerful microscope, you will see the different colors also. The different shades you will be getting, the different shades, the blue, the red shades, the green shades, the yellow shades you will be getting it. Which proves that it is being separated into its constituents. What is being separated? The ink is being separated into its constituents. This is called as paper chromatography. Now, what is the advantage of this chromatography? It can be carried out with a very small sample. Let us say 1 ml. I have taken it, ink 1 ml is enough. Alright, it's very useful in analysis of biomolecules. Later on, we will be studying the biomolecules such as sugar, amino acids, etc. Later on, in higher classes, you will be studying this. The substances used in chromatographic analysis are not wasted. Are we wasting this particular substance? No, nothing is wasted. What is wasted? Filter paper is there, ink is there, water is there, everything is there. Nothing is being getting wasted, isn't it? So in this way, this is known as chromatography, we can say that. Now here one thing you have to understand it. One thing is there, that is RF value. What is RF value? RF value means it is nothing but distance moved by the substance by distance moved by the solvent. Got it? What I said? Distance moved by the substance. Substance means this is a substance, this one, ink. Distance moved by the substance by distance moved by the solvent. I am writing it over this only. I think it is visible clearly to you. Distance moved by the solvent. I am writing over this. It is clearly visible. The RF value is distance moved by the substance by distance. How much distance this ink is moving from here to here? Let us say it's moving. And how much distance the solvent is moving? Solvent is moving from here to here. Any level? So distance moved by the substance by distance moved by the solvent will give you the RF value. RF value, that is known as. Okay. So understood what is chromatography. Next is separation of liquid gas mixture. How will you separate a liquid gas mixture? Simply by heating. Simply by boiling. For example, air is dissolved in water. How will you separate it? Simply you heat it. Simply boil it. On boiling, what happens is that the air comes out, or the gases which are dissolved in water, it comes out. So simply you can separate the liquid gas mixture by heating or boiling. For example, carbon dioxide is dissolved in water. How will you separate it? You heat it, you boil it. Water remains behind, carbon dioxide comes out. In the form of bubbles, you can see the gas, the air bubbles. Similarly, sulfur dioxide is dissolved in water. Or as I said, air is dissolved in water. A mixture of air and water, a mixture of sulfur dioxide and water, a mixture of carbon dioxide and water. How will you separate it? The liquid, the gas from the liquid. Simply heat it, simply boil it. On boiling, the water vapor comes out. When the water vapor comes out, you can see the bubbles also of the gases, you can see the effervescence, you can see that it comes out. What is that? That consists of the carbon dioxide molecule. That consists of sulfur dioxide molecule. That consists of the air molecules which comes out. In this way, you can separate a liquid gas mixture by boiling, by heating, we can say that. Clear? Because when you heat the water, what is the principal line behind it? When you heat the water, the solubility decreases. Whose solubility? The solubility of these gases decreases in the given solvent. Due to which, as the solubility decreases, now due to which this gas molecules comes to the surface of the water and it leaves the surface because kinetic energy increases and hence it leaves the surface. As it leaves the surface, the mixture gets separated. the air and water mixture or sulfur dioxide water mixture or carbon dioxide water mixture gets separated. Similarly, if you want to separate the gas mixture, gas, you can separate it by diffusion. Like one gas is lighter and another gas is heavier. How can you separate it? By diffusion. Lighter gas will diffuse faster, heavier gas will remain behind. Got it? Diffusion, you can separate it by. Got it? So in this way, what is diffusion? Diffusion is a phenomenon by which what you can say, the constituents of the mixture can be separated on the basis of its densities. We can separate it. It is a process of separation of two or more gases in which the constituents of the gases is separated on the basis of its densities. The gases which are lighter diffuses out faster. Alright, so diffuses out, that is called as effusion. When the gas diffuses out, that is called effusion. Mind it, effusion, E-F-F-U S-S-I-O-N, effusion, that is said to be as. And when it comes in, that is called as diffusion. We can say that. So, for example, you are having a mixture of carbon dioxide and hydrogen. Hydrogen is a lighter gas, it will diffuse out faster. Ammonia and nitrogen. What will happen is that ammonia is a lighter gas, it diffuses out easily. Then sulfur dioxide and nitrogen. Nitrogen is a lighter gas. The lighter gas, what happens is that it diffuses out because it can move out. It's a lighter. Suppose you are having a gas jar containing ammonia and nitrogen. So nitrogen will be definitely, it's a lighter gas, it will be above. So when you open the gas jar, nitrogen will diffuse out fast, leaving behind ammonia. We can say that. What you can say, that is ammonia will diffuse out fast, leaving behind nitrogen. Ammonia is a lighter gas, ammonia is a lighter gas, it diffuses out faster, leaving behind nitrogen. We can say that. Clear? In this way, diffusion, by the method of diffusion, we can separate the two gases based on their densities. Alright, but if two gases have got similar densities, then we cannot separate it by diffusion. If one gas is lighter and the other gas is heavier, the lighter gas will diffuse out fast, leaving behind the heavier gas. Got it? We can also separate it by using a suitable solvent. Suppose you are having a mixture of ammonia and oxygen. You can use a suitable solvent. What is that? Now, ammonia is soluble in Nessler's reagent. Ammonia is soluble in Nessler's reagent. It is soluble in Nessler's reagent. Ammonia is soluble. Ammonia gas is soluble in it. Nessler's reagent. So when you pass through Nessler's reagent, ammonia will get dissolved in it, leaving behind oxygen. Leaving behind oxygen. Suppose you are having a mixture of oxygen and nitrogen. What you will do? You pass it through alkaline pyrogalal solution. Alkaline pyrogalal solution. Alkaline pyrogalal solution, where oxygen will dissolve in it, leaving behind nitrogen. In this way, by using a suitable solvent also, you can separate the gaseous mixture. One of the component will dissolve and other will be remaining, what you can say, will be undissolved. Other will be undissolved. So the one which is undissolved, separated. You heat it, it is being separated. Got it? In this way. So you can separate in this particular way. Another one also you can do it by preferential liquefaction. One, if suppose the two components are there, one liquefies faster than the other one. Like ammonia and hydrogen is there. Ammonia liquefies faster compared to hydrogen. So in this way, there are several methods are there. You can gas mixture, you can separate it by the method of diffusion on the basis of densities. You can separate it by the using suitable solvent, as I said. You can separate it by using preferential liquefaction. In preferential liquefaction, one liquefies faster than the other one. Both are having different, what you can say, liquefying power. Alright, in liquefaction, what happens? The molecules, they come closer together and they changes from gaseous state to liquid state. So in case of ammonia, this is being done faster because ammonia molecules, they can come closer to each other and they can easily change from gaseous state to liquid state. Compared to hydrogen, we can say that. Compared to hydrogen. Compared to nitrogen, we can say. Clear? So certain molecules, they have that particular intermolecular forces stronger so that they can pull the molecules together. They can come closer and hence they can change their state from gaseous state to liquid state. It can be done in this way. So these are the different methods by which you can separate a gas-gas mixture, gas-liquid mixture and chromatography. I hope you understood. Thank you.